the session so far and on the recording now. All right, so just review real quick. All of these systems here belong to a single collision domain because they're tied together with a hub, which is a physical device. The more PCs connected to the hub, the more nodes connected to the hub, the more possibility for collisions, and the more collisions, then we basically degrade the performance of the network. So what we did was we said, okay, well, how can we improve this? And what we did was we created a device. First, they were called bridges. Later on, we called them, or we created switches. And switches are nothing more than high-density bridges. In other words, they have many ports on them. And in fact, this particular switch is very similar to the switch that we have in our classroom. And we can take a look at it. You can see it. This is a picture of it right here. And I don't know if you've ever taken a look at our switch in the classroom, but it's probably a Catalyst class switch, very similar to this one right here. So we've got this switch sitting in the middle now. And now what we want to do is we want to try the test that we had before. Hey, Darren, how are you tonight?
I'm fine, Jim. How are you?
I am good, thank you. All right, so we've got the switch, and I'm going to generate some traffic on it. Let me get rid of those, and let me set up a new scenario. So again, we're going to go from PC2. Okay, I hope. Okay, we got a problem. I have to go in and configure this real quick. So I'm going to configure this PC real fast. 192.168.1.5. And we'll configure this one. 192.168.1.2. Figure this one. 192.168.1.3. And close that. One 192.168.1.4, and finally 192.168.1.5, and we better do the switch because I imagine the switch doesn't have its IP address. How did I just blow that away? 192.168.1.5. Why do they keep doing that?
You already used 1.5, I think.
Okay, that's 1.4. And that says it's not set. So try it again. Okay, let's turn off the simulation. Try one more time, otherwise I'll name it 1.6. This address is already in use in the network. Okay, fine. So we'll do 192.168.1.6. That should keep it happy. All right. So that's 1.6. Okay. Again, we'll test our connectivity. We'll go into our command prompt, and we'll ping 192.168.1.6, and you can see that we're talking to it. So that's good. Let's just check our router here. Our router needs to be set to 192 168.1.100. And that looks good. Okay, good. All right, so let's set up our test. We're going to grab our little packet here, and we're going to go from PC2 up to PC5. And now we're going to basically say, let's start the simulation. So watch what happens to the packets. Okay, so the packet goes to the switch. Now, previously with the hub, what happened with the hub? The packet went out where?
It went to every device.
Yes.
To every device, but it only recognized the PC5, the one they were supposed to go to.
Exactly. So let's see what it does. Okay? Well, that was very interesting. Notice what it did. Okay?
It went straight to PC5.
It went straight to PC5. Okay? Went straight to PC5. Now, I'm going to turn off the, or what I'm going to do is I'm going to go into this router, and let's see. I'm sorry, into the switch. And what we're going to do, we're going to reset it. And let's see if what it does here. Now, the switch does what? Okay? If you notice, go ahead.
The switch basically, when it reads the packet, it basically scans it for the MAC address that it's supposed to go to, so that way it gets right from the computer.
Okay, and that's why a switch is a data link layer device and not a physical device. Okay? It has physical device capabilities. In other words, it has ports in order to communicate, but the switch looks at MAC addresses. So if we look at one of these things, let's do this. If we look at one of these packets, what you'll notice is that it's received in on a port on the switch, and then the next thing that it does is it takes it and it basically looks for the MAC address and looks to see if the address is in the MAC table of the switch. This is a unicast frame because it's basically a ping, and the switch looks in the MAC table for the destination address. We go to the next layer and it says that the outgoing port is an access port, so the switch sends the frame to that port. All right? So it sends it out to port Fast Ethernet 01. So the packet came in on 04 and it's going out on 01. So what it's doing is it's literally looking at the MAC address and it's determining which way to send this particular packet. And if we look at this, okay, if we look at the packet, what we see here is we see the destination MAC address, which is the MAC address for our PC2, and then the source MAC address, which is our PC5. And that's inside the packet that's being processed. So, when you have a switch, okay, how many collision domains do I have here? In this previous example, we had one big collision domain. What do I have here?
Well, you don't have any collisions because it's able to read the MAC address.
Okay.
Your last one, you had 4 collisions.
All right. So, with the switch, you're saying we don't have any collision domains, correct?
Mm-hmm.
All right.
Yeah, one, because the PC2 has to go to the switch, but that's not considered a collision, right?
Well, let's put it this way. You're not going to have any collisions on the connection between PC2 and the switch. All right?
Okay.
But technically, guys, if they ever ask you in the test, we have 1, 2, 3, 4, 5, 6 collision domains. Each one of these connections, each port on a switch is its own separate collision domain. Okay?
Oh, okay.
Okay.
So the beauty is that because there's only one device on that connection, there are never any collisions. Okay? So the switch has allowed us to get away from collisions. All right? All right. So that being said, let me show you another network, very similar. Save that one, and then we'll pull up this one. No, that's not the one I want. That's the one I already have. This network is called collision versus broadcast. All right. Now, can anyone tell me how many collision domains do I have here? How many
12.
collision domains? 12?
12.
Okay. Actually, we have 8. 8 collision domains. Yes.
8. Let's see. 1, 2.
You don't count the routers?
No? You do.
9, 10, 11. I count 12.
Okay. All right. You count 12 connections, Darren, but they're not 12 collision domains. Okay? Remember, what's the definition of a collision domain? A collision domain is a set of computers or a set of devices that must share a network medium, okay? And that if either one of them attempts to communicate at the same time, all right, we're going to have a problem. Okay, we're going to have a collision. So if 2 or more communicate at the same time, we're going to have a problem. So
it's the hub, the switch, and the 2 routers.
all right, yeah, you're just about there. So you've got this. That's a collision domain, including the router. Okay. As Nick said, this connection right here between the routers, that's a collision domain. All right. And the router, each one of these connections to the switch is its own collision domain. Remember, with a switch, every port on a switch is its own collision domain. Where a hub, everything connected to a hub belongs to the same collision domain. So this is all one big collision domain. And then these 1, 2, 3, 4, 5, 6. So the number we have is 1, 2, 3, 4, 5, 6, 7, 8.
Okay, all right.
All right? And it's all, yeah, it's all because we're using hubs in one case and we're using switches in another.
How much longer?
I'm not sure why.
Because you need to hit the road.
Hit the road. It's only 7:30.
Who's the head, Adrian?
That's my sister.
Your sister. She wants to go, huh?
Yeah, we're going to the mall.
Okay, yeah, that's where my crew went tonight. Or my daughter and my wife went to the mall.
Yeah, I'm the only one that drives the highway, so I gotta go.
Really? All right, well, we'll record
gonna
it for you. I'm recording it right now, okay?
All right, thanks a lot, Mr. Ball. I'm sorry.
That's okay. That's okay. I know it's tough, especially with school coming on for the fall. Everybody's trying to get ready, and that's what
That's what
my
we're going to
granny's doing.
get her school clothes and school supplies and all that crap. So.
Okay, very good. Look for an email. I talked to Nick about this morning about how I'm going to get you guys some extra credit and so on. And I came up with an idea last night that I think everybody's going to be pretty happy with. So I'll put together, describe it in detail tonight after we finish up, and I'll email it out to everybody, and then I'm going to be asking for your feedback. Okay?
All right, great.
All right.
All right.
Have a good night.
Everybody, you too. Everybody have a good night.
All right.
All right, you too.
Talk to you soon. Okay, guys.
Mr. Buck,
Yes.
Mr. Buck, can I ask you a real quick question?
Go ahead.
Like, I want you to know that now that I know my app works perfectly fine with this, I'm never missing this. I wish I would have did this in the beginning of the year, because I'm literally, I know I'm not supposed to. I'm not, like, my hands is not touching my phone, but I'm literally driving.
Oh, okay. You're driving. He's driving with this damn thing. All right. Well, keep your eyes on the road and listen, okay? Great. That's all I need is to hear you in the news.
Hello?
Okay. Yeah. We heard you. You were a little garbled there.
Okay.
All right. So let's see. And Tremaine is out there, but I don't know if he can hear us or what. Tremaine, if you can hear us, send us a message and let us know. Oh, there he is. Yes, he can hear us. Super. All right. So, guys, one of the reasons why we create subnets is to break up collision domains. Okay? And as we know, if you have a really large collision domain, what that's going to do is it's basically it's going to degrade your network's performance. The bigger the collision domain, the more collisions you have, the slower the data is going to move through your network. That's why you rarely see hubs anymore in networks. Okay, we generally use switches because switches, what they do is they break. We call it microsegmentation, where we break a collision domain into simply the switch and a device, switch and a device, switch and a device. So each one of these is an individual collision domain. All right. Anybody ever heard of a broadcast domain? Anybody know what a broadcast domain is?
Is there a router? Oh, no, wait.
Okay, I'm going to give you a little hint. Broadcast domains are always separated by a router. Okay? Broadcast domains are always separated by a router. So based on that definition right there, can you tell me how many broadcast domains I have in this diagram? How many routers do I have?
Yeah, actually you have one.
This is a router right here.
Two.
Yeah, one,
And
two.
so I've got two routers. So tell me.
Yeah.
Go ahead. How many broadcast domains do I have?
Yeah,
Two.
Nick, you want to take a shot?
I still say one.
Okay, Tremaine's saying 2, then he's saying 7. Okay.
I say 2, but you got a switch there too.
Yep. Okay, there are 3 broadcast domains.
Okay, all right.
Okay.
All right.
And again, the reason for that,
Well, he said that it's separated by a router, so... Oh,
so if you will, this is a broadcast domain right here. This is a broadcast domain right here. And this is a broadcast domain. Okay? So Do you know what we use broadcast domains? Broadcast domains are actually functionally needed. We need to have the ability to have broadcast. Collisions, on the other hand, are something that we do not want to occur. We want to minimize the number of collisions. But broadcasts are something that can't be helped. Who knows what DHCP is? DHCP. What is that, gang? DHCP means Dynamic Host Configuration Protocol. Does anyone recall what Dynamic Host Configuration Protocol does for us? Okay, should have had that in your protocols class.
Figures out our MAC address?
Well, it doesn't figure out the MAC address. What it does is DHCP, when it's running on a server or a router, hands out IP addresses.
Oh.
Okay? So if a host basically connects to the network and turns on, what happens is DHCP will hand out an IP address for that machine. Now, when the host first starts up, namely a PC first starts up, and it's going to use DHCP, the very first thing it does is it sends out a broadcast to everyone saying, I need an IP address. All right? So it literally sends that message out to everyone. Okay? And it has a very specific MAC address. In fact, the MAC address is all Fs. All right? And what that tells the switch is that this packet is not for a specific PC, but is to be broadcast across all systems. Okay. So one of the things that we try to do when designing a network is we try to break down the broadcast domains. Nick, are you trying to say something? We lost Nick. Okay, well, hopefully he'll come back. All right, so again, one of the things that we try to do is we try to keep broadcast domains smaller. Because, again, the bigger the broadcast domain, the more traffic we generate. So a lot of times we try to keep them limited. Tell your son I can see him.
Yeah. That was my teacher, Josh. Teacher team.
All right. So, a lot of times in order to break up a broadcast domain, what we do is we'll stick in a router. All right? And as soon as we do that, as soon as we stick a router in, the thing that we have to do is that each broadcast domain must have a different subnet. All right? So this broadcast domain over here, we're going to give it the subnet of 192.168.1.x. Okay? This subnet over here is going to have 192.168.2.x. All right? And then finally, our third subnet up here is going to have 192.168.3.x. All right? So again, each broadcast domain gets its own subnet. And by the way, whenever we talk about subnetworks, okay, and we give an address, what do we need to follow with that? What else? What other piece of information do you need to know? The IP address? Not quite. What else do I need to know?
You need to have you need to have. What's that?
Okay, I missed that, Darren.
Oh, what MAC address is connected to it, or?
No, I don't need the MAC address. I need to have,
What map? You have the IP address. You have subnet mask.
the subnet mask.
Okay.
Now, Darren, you were in the class last week, correct?
Mm-hmm.
Okay, so
Yes,
this slash 24 identifies the subnet mask, correct? And what notation is that? Do you recall?
24. I think that is.
No. What notation is that? What format is that? We called it a special notation.
Oh boy. That's three. That's actually three.
Well, it's equivalent to 255, 255, 255, 0.
All right.
All right? But the notation that we call it is CIDR. CIDR notation. CIDR.
Okay.
Remember that?
All right.
Okay.
Yes.
So, yes, correct, Jermaine. Thank you. CIDR is the notation. I'm trying to keep an eye on the chatting. Okay. So anyway, again, every broadcast domain has its own subnet. All right. So if every broadcast domain has its own subnet, and let's say that I've got, let's do this. Let's grab all of this and slide it down a little bit. And I'm going to take this out here. And then I'm going to take this, and we're going to go from here. All right, fine. Be that way. See if I can. Let's grab this, and we'll grab a. Oh, come on. 1 second, guys. Sorry.
Sorry.
Let's try something else. There we go. That'll work. Okay. Oh, that's what's wrong. I need a port. Sorry. Okay. Let's see. Let's grab one of these. That'll give me an additional. Oh yeah. It wants to be powered off first, and then we got to add it. There we go. Power it back on. Now we can do this. All right. This is my ISP up here. Okay? Now, can anyone tell me how many broadcast networks do I, or broadcast domains do I have based on this diagram?
You actually have 4 now, because
Correct.
One up top here, one there, and then that switch.
Yep, so we added this fourth broadcast domain right here. All right? So this is my router back in the office here, and then this is a router, let's say, in another part of the building. All right? Now, generally, between your ISP up above and your corporate router down below here, what type of IP address do we normally get? Is it a public or a private IP address?
think that is private.
Huh?
It's for. Well, I'm not totally for sure. It might be public.
Okay.
Not
Might be
totally
public.
sure.
Okay. Generally, what happens is we get public IP addresses, all right? Because if you will, this is considered the internet. Your ISP at this point is considered the internet. So in order for this router in your corporate office to communicate with this router, it's got to be able to communicate on the internet, and therefore we must use public IP addresses. These systems back here could use private IP addresses, and today that's generally what we do. However, long ago we didn't have the distinction between public and private, and that's where subnetting really became very important. So I would go to my ISP, and I would tell my ISP that I need X number of IP addresses. Now, the number of IP addresses that I need would be based on what, guys? What determines the number of IP addresses that I need?
Your subnet mask?
No, not quite. Anyone else?
Oh, your broadcast network?
Well, it's going to depend on the number of hosts that I have. Your network connection. Not quite, Tremaine. Okay? It's going to depend on the number of connections that you have, the number of hosts that are in your network. All right? So, let's just count them up. How many hosts do I have? I actually have 1, 2, 3, 4, 5. Okay? Should I count the hub? Can I give an IP address to a hub?
No.
Generally, hubs do not have IP addresses. However, there are hubs that we call managed hubs. In other words, you can manage them remotely. If that's the case, they get an IP address. So I'm going to give the hub an IP address. I've got a router here. Okay? How many connections does the router have? How many broadcast domains is this router connected to?
2.
Connected to 3. 1, 2,
okay.
3.
Yeah.
Okay? So each connection has to have its own IP address. Okay? So I've got 6 IP addresses down here. I've got 3 IP addresses here. So that makes a total of 8 right now. Okay?
Oh, okay. All right.
Now, over here, I've got 1, 2, 3, 4, 5 machines. I've got my switch. So I should have 6 IP addresses. How many connections do I have on my router?
6.
I've got 2. I've got 1,
Okay.
2. 1, 2. Okay? So I've got 8 here, 8 total here. And I have, what did I say I had over here?
8.
Was it 8? 3, 4, 5. Yeah. 6, 9, 15, and I need one more right here. Okay? I need one more. So I need 17. Okay? I need 17 IP addresses. I need 17 public IP addresses. And this is where it becomes extremely important. Okay?
Yeah.
Now, based on 17 IP addresses, all right, how many bits do I need to represent 17 hosts? If you recall our formula, okay, that the number, yeah, who's this? Yeah?
Yeah.
Good, you're back.
Yeah, I'm back.
think since you need that many, I'm thinking that you have to have at least about like, you have to have 5. Am I right?
Yeah. Hey, would you do me a favor? I'd like you to mute your mic because I'm getting a lot of feedback on your line. Okay. There you go. Perfect. When you've got a question, just take the mute off and ask the question if you would. All right, guys. So the number of hosts, okay, the number of bits that I need is going to be based on 2, and if you remember, asterisk asterisk means raised to the power of the number of host bits minus 2. Okay? So if I have, for example, if I have, wow, what the? Tremaine, you're making a lot of noise. All right. So let's say that I take 3 host bits. So I take, let's go back here. If I take 3, or I'm sorry, 2 raised to the power of 2, or 3, minus 2, what does that give me?
5.
Well, 2, what is 2 to the 3rd power?
To the 3rd power
8.
is 8.
8.
So if I take 3 host bits, I'm only going to get 6 hosts. Now,
Yeah.
we said we need 17 hosts, right?
Yeah.
So how many bits am I going to need? How about if I take 4 host bits?
That still wouldn't be
4 host bits, 2 to the 4 would be 16, minus 2 would give us 14. That's not enough. So
Yeah.
2 to the 5, which you had said earlier, Darren, okay?
Yeah.
2 to the 5 gives me what? 2 to the 5.
Let's see. 4, 3 is 8. Then 2 more, 16. 16. That gives you 34.
You
And less 2 would give
You and Jan
you
need to split the difference, okay? It's 30. It's 32. 2 to the
Yeah.
5 is 32, okay? Minus 2 is 30, okay? So if we say 2 to the 5 minus 2 equals, well, 2 to the 5 is 32, minus
Yeah.
2 equals 30. So that's more than enough, don't you agree?
Yes.
That's more than what we need, all right? But actually, we need a little room for growth, and we also need to have, we actually have to set up a couple of small subnets, all right? Now, the question here is, how many subnets do I need? Okay? Your number of subnets is equal to your number of broadcast domains. So how many broadcast domains did we say we had?
One, 2, 3, 4.
Correct.
5.
We have 4. We have 4. So I've got one here. I've got a broadcast domain here. I've got a broadcast domain here in between these 2 routers and a broadcast domain over here. But not all of them have the same number of hosts in them, okay? All right. So let's do this.
Jim, can I ask you a question, though?
Yes.
I do remember you saying that you were going to change that hub to where as though it was going to be where you can actually put an IP address on it. That's why I was saying 5. I remember
Correct.
when you said.
Yeah, but even though that the hub has an IP address, doesn't change the fact that this is one broadcast domain right here.
Okay. All right.
Okay.
All right.
All right.
Because that got me. That tricked me there.
All right, very good. So what we want to do next is we want to try to figure out how many subnetworks do we need. And what we're going to do is basically I need to have, I need to get, let's see. Let me give you an IP address, okay? I am going to give you an IP address of, let's see, our dot 0 with a slash. Now, if I have 6 bits, do you recall what the subnet mask, if I need 6 bits for my host, or what was it, 5 bits for the host. If I need 5 bits for the host, I need to have 255, 255, 255, and then I need 8 bits. So if you recall back to our table, do you remember our table that we had? Let me pull that up and just grab that. There's our table. And I wish it hadn't done that. All right, so our table's there. If I'm going to do 5 bits, notice the 5 there. It's a 248, and that shows us 5 bits. Correct? With 3 bits left over for our... oh, I'm sorry. No. It's 5 bits for the host, which means I have how many bits left over for the subnet mask?
3.
3, correct. So it's 224. So I'm going to go over here, 224, and this is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 1, 2, 3, 4, 5. Okay, that's what the subnet mask looks like. The 224 represents 3 ones and 5 zeros. Okay?
Mm-hmm.
All right, very good. Now, I need how many, and now I'm going to do this. All of the ends represent network bits, okay? Now, what has happened is my ISP has given me 30 IP addresses. I need 17, but they've given me 30, okay, so that I have some room to grow. Now, what I have to do is I've got to take those 30 IP addresses and I've got to divide them up amongst 4 subnetworks, okay? So in order to have 4 subnetworks, does anyone recall what the calculation is for a subnetwork? Okay, it's the number of subnet bits, or, yeah, I'm sorry. It's 2 raised to the power of the number of subnet bits is equal to the number of subnets. So I've got 4 subnets I've got to create. Can someone tell me how many bits I need to get the 4 subnets? 2 raised to the what is going to give me 4. What power of 2 gives you 4, gang?
2.
Very good. 2. So I need to take an additional 2 bits. So over here, I'm going to use S to represent my subnet bits. Okay? And what I want you to do is, you see this last S right here? That may be a little small for you guys, but can anyone tell me what bit is that sitting on? What's the value of that bit right there in binary? 8. Correct. Correct. It is a value of 8. All right? We call this our block size, and it is the last rightmost bit, okay, that is being used for the subnet. So what I'm going to do is I'm just going to jot down, here are all of my subnets. 0, 8, 16, 24, and the next one up is going to be what?
48.
32. 8 plus 24. Okay? Now, my address range from my ISP, what my ISP is giving me, is the address range. Let me just write down the CIDR notation. CIDR notation is 2427. All right. The address range that my ISP has given me is 0 through 31. Okay? So we're not going to be using this block here. We're not going to use that block because it's too high. It's above what we need it to be. All right? All right. Now, so right off the bat, I know that I have 4 subnets, and I know what the network addresses of those 4 subnets are. Okay? And gang, if you didn't see if you weren't with us last week, you need to look at the video from last week to really understand where we're going next. If you recall, when we figured things out, we said that we needed to know 4 things for every subnetwork. We needed to know the network address, we needed to know the first host, the last host, and the broadcast address. All right, so let me subnet number 1. The network address, let's do it this way. Subnet, then network address, first host, last host, broadcast address.
Hold on a minute, Jim.
I need some room to write here, gang, so I'm going to move this around a little bit. All right. So, my very first subnet, okay, and I'm only going to be playing with the 4th octet, guys. I'm not going to worry about the 12, 235, 42. I'm only playing with the very last octet. So my very first subnet is going to be, subnet number 1 is going to have a network address of 0. So that's 12.235.42.0. Okay? My second subnet is going to have a network address of 8. Can anyone tell me what my third subnet network address is going to be?
16.
16. Very good. And then finally, my fourth subnet is going to be 24. Okay? Now, the first host is always one above the network address. So the first host for my first subnet is going to be what? What's the address for the first host?
1.
Very good. For my second subnet, my first host is going to be 9. For my third subnet, my first host is going to be 16 or 17. And then finally, for my fourth subnet, my address, my first host, is going to be 25. Thank you, Tremaine. Okay, very good. All right, guys. Now, this is where it gets a little difficult, okay? Trying to figure out the last host. Well, guess what? When you've got something like this where you've got multiple subnets, your last host, okay, is always going to be, basically one less than the next network address. So and I'm not going to do the last host, I'm going to do the broadcast address. So the broadcast address here is 7, all right? Can anyone tell me what the broadcast address is for subnet 2?
15.
Very good. Excellent. Somebody else want to try subnet 3? What's the broadcast address?
27?
No, actually it's going to be one less than this right here, Darren. So it's going to be 23.
Okay.
Okay? Now, recall that my next block up is 32 because we don't have another subnet up here. And why did I put 6 there? All right. So this right up here is going to be 31. Okay, good. Yes, thank you, Tremaine. All right. So, does everyone see that? Okay? Does everyone see that? All right. Then let's figure out the last host. The last host is always one less than the broadcast address. So, we're going to do 6. We're going to do 14. We're going to do 22. And we're going to do 30. Okay?
Yeah.
Now, take a look at this. Between my first host, number 1, and my last host, number 6, so I have how many host addresses for my first subnet? How many host addresses do I have? 5? 1, 2, 3, 4, 5, 6. I've got 6. In fact, every one of my subnets has 6 addresses. Now, that just worked out very nicely because guess what? Look at this. This subnet, how many IP addresses do I need?
6.
I need
No.
6. I really, if I were going to do this properly, I need to have 7 if I were going to assign an IP address to the hub.
Okay.
Okay? But I need one for the router, and I need one for each one of the PCs at a minimum. Okay? Correct, Tremaine. I need to have 7. But 6 is what we're going to assign. Okay? We're not going to give an IP address to the hub, and we're not going to give an IP address to the switch. All right? All right. Very good. All right. So, does anyone see a problem with this? I thought we said that we were going to have like 30 IP addresses and we only needed 17, but I'm already running out of IP addresses. What's the problem here? What is the problem? I know that I got 30 addresses from my ISP, okay? But yeah. I'm already running out of IP addresses because I don't have enough here. Okay? Here's a question. For this network right here, between these two routers, let's call that subnet number 3. How many host addresses do I have for subnet number 3?
24.
No. Take a look. Subnet number 3.
Oh,
First host address, last host address.
it's only 8. No, wait. That's only 5.
Did I screw something up? Oh, don't forget to count 17, okay?
Okay. 6.
17, 18, 19, 20, 21, 22. So 6,
6, yeah.
okay? All right, so I've got 6 addresses. How many IP addresses do I need for subnet 3? How many IP addresses do I need here?
8?
Well, I only have 2 connections on this entire subnet. I only have the connection on this router and the connection on this router. I only need 2 IP addresses.
Okay.
So as a result of that, I am wasting 4 IP addresses. I'm wasting 4 IP addresses. Okay? How about this subnetwork up here? Let's say that this is subnetwork number 4. All right? How many IP addresses are we giving subnet number 4?
6 again.
We're giving it 6. How many do I need? Yeah.
2.
I only need 2. An IP address for this router, an IP address for that router. So again, I'm wasting, okay, another 4 IP addresses. Okay? All right. This is a typical problem. This is a typical problem, okay? In your classes, have you talked about variable length subnet masks? VLSM. Okay. VLSM is a technique that we use to basically conserve our IP addresses. But I'm not going to get into that tonight, okay, because that would just blow your minds.
Yeah, I'm sure it would.
All right? Now, in this exercise that we have just gone through, that I have just spent an hour on, okay, what I've been trying to do is I've been trying to hey, is that your son? He's going to come to school.
Yeah. It's my son Kyle.
Very good. Hi, Kyle. Say hi, Kyle. How old are you, Kyle?
He just turned 2 in February.
You going to help Dad with his homework? We see you waving. All right. So what I wanted to do here was I wanted to explain why do we subnet and just kind of go through a basic example of subnetting. So subnetting is taking a limited number of IP addresses and then spreading them around to the different subnetworks that we have in our network. So in our network, we've got 4 subnetworks. We've got, again, this one. We've got this one up here between these 2 routers, this one between these 2 routers, and this one right here. But these subnetworks basically have different sizes. Right now, we're just going to go with a fixed size subnets, okay? Don't worry about the variable length subnets right now. Just fixed size. So, having said that, and use this diagram, we're going to get rid of the diagram now, and we're now going to talk about creating subnets, okay? All right. So I'm going to, let's see, I'll just open up my notepad. And here it is. I'll tell you what, rather than notepad, let's do this in something that I can vary the font size. We'll do this in WordPad. All right, and what we're going to do is we're going to increase our font size. Okay, that's big enough. Can everybody see that? Is that big enough?
Yeah.
All right. Very good. Okay, so here's the problem. Okay, I've got a network now that has 5 subnets, and each subnetwork needs to have a minimum of 30 hosts. Okay? So, I've got 5 subnets and 30 hosts per subnet. That's the problem. All right. Using our equation, in terms of the number of subnets, if we say 2 raised to the power of number of subnet bits equals the number of subnets. So if the number of subnets equals 5, that's what I need. I need somebody to tell me how many subnet bits do I need to have, okay? Okay, I wasn't watching any of the chat messages. Did anyone have a response to that? Let me check.
Hold on a second, Jim.
Okay.
You got 30 for each subnet?
I've got
30
hosts for each subnet, but I need to have 5 subnets. Darren. Okay, so if I need
Mr.
5,
basically 2 to whatever.
right? So that's the question, Nick. 2 to the what
So
is
should be 3. It should be 3, correct?
No,
correct?
2 to the third power. 2 to the third power.
2 to the third. Yep, that's it, guys.
Yeah.
Two to the third equals 5.
No, it equals 8.
No. 2 to the third. Okay, hold on.
And we subtract 2. No. And that still don't equal 5.
Yeah, okay. What happens if I take 2 to the 2, Nick? What do I get with 2 to the 2?
I get 4. All right, but you need 5.
Oh, so you'll be less. You'll have less than 5. You got to have greater than 5, right?
Yeah.
Yeah.
Sometimes you can't get a perfect number. You can't always get a perfect number, okay?
Okay.
So, all right. So we're going to take 3 bits, and we're going to end up with 8 subnets, all right? Now, let's say that my ISP gives me the following, okay? Let's say 164, 78, 25.0/24, okay? The /24 says what?
What's the crap? I forgot this. Subnet. No.
24 hosts? 24 host bits?
Well, the 24 subnet bits, okay?
24 subnet bits.
So, if we go down and we change our subnet, we basically write out our subnet in binary: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So how many ones do I have there?
24.
I have 24 ones, okay? So all of this represents so when my ISP gave me this IP address, what they're saying with the /24 is that the first 3 octets belong to the network address, okay? Everybody see that?
All right. Yeah.
Can anyone tell me if I were to write this in a dotted decimal format, what the subnet mask would be?
Two five five, 255, 255, 0.
Correct. Okay, there it is. All right. The only reason I spaced it out that way, gang, is so that you would see that this 255 represents these ones, this 25 these ones, 255 these ones, and this 0 represents these 8 zeros. Okay? So that's what my ISP gave me. Now, we just determined up above that I need to borrow 3 bits out of this subnet mask in order to have 5 subnets. So what I'm going to be doing is I am going to convert this, and we're going to change it up a little bit. And really what I need to do is I need to change my font to anybody know why I used Courier as my font?
It's easier to see. Or is that how it comes out when you print it?
What happens is Courier is what we describe as a non-proportional font. So what happens is everything lines up very nicely, okay? So if you're ever doing anything where you want things to line up real nice, use the Courier font. All right, so I've got, that is my network portion. That is my host or my subnet portion, and that is going to be my host portion in red. Okay? So that should make it relatively clear. Now, you recall that we did say that we are going to take 3 bits to divide this up into subnets, right? Can anyone tell me, looking at this one S here, what value does that S represent in terms of base 2? Okay? What's the value of that S right there?
32?
Correct. The first...
Is it 32?
That is correct. The first S is 128. The second S is 64. The third S is 32. That tells me that 32 equals my block size. And as such, my blocks are going to be 0, 32, 64, 96, then what?
128.
128. Then 160. Okay. And how many subnets do we need?
3.
Well, we needed
5.
We needed 5.
Oh,
We needed 5 subnets.
Right.
But how many subnets did we end up getting? We ended up getting 8. Okay, but we only need 5. So we got 1, 2, 3, 4, 5 right there, and 160 is the upper end, which we're not going to go after. All right. Cool. We're in great shape so far. Now we're back to the point where how many bits do I have for the host address? How many bits left over do I have for host?
5.
I have 5. And recall, what is the formula for the number of hosts? The formula is
2
raised to the number of host bits minus 2. So if I have 2 raised to the 5 minus 2, that's equal to 32 minus 2 equals 30.
Good.
Okay? And recall, we need to have 30 hosts on our subnet. All right? Is everybody cool?
Yes.
All right, very good. I'm going to change this around a little bit. Yeah. So, knowing that, now we're ready to go and answer the questions. Okay? Subnet number. Okay. Network address. First host. Last host. And broadcast address. And we need to just expand this a little bit. Oh, that was not good. What did I just do?
Can't you just control U?
Oh, I see what I did. I
mean control Z.
what happened was I moved some of my
Yeah, but Jim,
Okay.
can't you control Z and it'll go back?
oh,
I wouldn't do that.
you know, Nick, I never knew that. I never knew you could do that.
I wouldn't do that. I would leave it just the way it is, BC.
Okay, all right. I don't know. I have to screw with it. Tell you what, let's
Well, how about
see.
trying to press the one on the left side? Try pressing the one on the left side to move the whole
All right, let's try that. Yeah, it's not allowing me to move it. All right. We'll survive. We'll be okay. So I've got subnet number 1. And recall, look at your, use your blocks, block numbers for your network addresses. So I've got 0 is my first one. 2 is 32. 3 is 64. 4 is 96. And 5 is 128. Okay? Again, what's my my first host address?
One.
Okay, my first host
So would
address
that be
is
like-
going to be 1. What were you going to say, Nick?
No, I'm following.
Okay. So on my second subnet, what is my first host address?
33.
33. Very good.
Oh, okay.
Next.
65.
Very
Right.
good.
97.
97.
97. And then finally, 129. Beautiful. Beautiful. All right, good. Now, don't worry about the last host, okay? Let's concentrate on our broadcast address. So our broadcast address is going to be what? How do we figure out that broadcast address?
There's always one lower than the second subnet
There you go.
net address, right?
Right. So what is it, Ya?
31.
31. Beautiful. Okay. Next.
63.
Very good. You guys are getting this. 95. And then 127. Now, what's this one?
It's 158.
Close. 159.
Oh,
Okay. Remember the block size over here, or the block? 160. Okay. All right. So now all we need to do is fill in our last host. So our last host is always going to be one less than the broadcast. 30.
Okay, 60.
62.
95.
94. 126. And 158.
And this is subnetting. No.
This is subnetting. This is
All right, cool.
subnetting. Okay. Now,
I'm gonna have to watch
there are still a couple of things here that I haven't shown you with respect to subnetting. There are a couple of configurations that, if I were to throw them at you, would probably confuse you a little bit. So I'm not going to do that to you tonight. All right? But what we'll do is in our next session, we're going to talk about, one, some of the crazy circumstances that we can get into, and two, we'll talk about, what is it? We'll talk about variable length subnet masks. Now, if you would like to practice subnetting, okay, I can show you where you can get some excellent subnet questions. Let me just pull up my system here. Canvas. Things running slow. Okay, let's see. Oh, that's right. It was in the old system.
Jim, this gonna be on YouTube tonight or no?
I didn't hear that.
No, is this gonna be on YouTube or no?
Yeah, I'm recording this now.
Is
Okay.
this gonna be on YouTube tonight? Okay.
It will not be on YouTube tonight. Okay. I will probably have it converted and have it on YouTube by the weekend.
Okay.
Okay. Let me take a look here. Supplemental. All right, guys, I've got to look for this link. Actually, one of my students gave me this, and it's really a great website. It shows you how to, it basically asks questions, and then it comes back and it gives you the answer. All right? So what I'll do is I'm going to probably do a couple of those questions just to show you how it works, and I'll record that as well, and I'll post that up there. Here is our link for part 2, which was last week. And so we'll say new. Sorry about that. Say here. And let's see, I want blast email. And I want subnetting. And I want to send that out to everybody, so okay, there are all of your IP addresses, and we are good to go, and here it comes, guys. Okay, so that email is, and that will have the video link from last week, and then I will post the video link for this week along with a supplemental video showing you how to do the problems online. Okay? All right. So I'm going to leave that here. I think this is a good place to break it off. And again, I'll be sending out another email talking about how we're going to get some extra credit, if you will, and get some of our scores up, you know, for the final and so on. Okay?
Okay.
Okay. And the final is going to be the last week of class, correct?
Correct. Which is the day after Labor Day.
2 weeks, right?
Yes.
Okay.
That is correct. All right, Tremaine, you just got back. What, are you at work now? All right, guys. So I'll talk to you next week. Let me just fill Tremaine in as to what we're doing here. I'll also take this this WordPad document here, and I'll send this to you as well. Okay. As well as I'll send you a snapshot of this as well. All right. Okay, guys. Have a good week.
Mr. Bo, is there any way I can get this? You too, Mr. Bo, before you go, is there any way I can get the Cisco packet tracer? Or I have to buy it?
I'll tell you what, y'all. What I can do is I can work something out with you when I see you on Monday, okay?
Okay.
All right, very good. Yeah, this is a great program to have. Definitely a good program to have.
Yeah, because I have to do a network diagram, and this would be great.
Actually, if I were going to do a network diagram, I'd use Visio instead.
Okay, well, I have Visio, so I'll use that.
That's a lot easier to deal with, okay?
Okay. Well, I think I have to do the work of where IP addresses are going inside the route. That's why I said I wanted to try this. Because with Visio, you don't have to do all that.
Well, yeah, Visio, you'd have to do that, but you'd have to, in terms of your presentation and so on, this is not going to do a good job of showing you that.
Okay.
You're much better off with Visio. If I were doing what you were doing right now, I'd definitely do it in Visio. I would not do it in Packet Tracer.
Okay.
All right, guys?
Thanks.
All right.
All right.
Thank you.
Have a good night. Okay. Take care.
Thanks.
Bye.
Well,